So we pointed out the graph of the exponential function either looks like this or like this, not both, just one of the two, either just that or just that. And so the point is it's one-to-one. You can see from the graph that it's one-to-one, and so it has an inverse function. And so we can define that. So definition, so given f of x equals a to the x, I won't write it, but I'm assuming, as always, a is bigger than 0 and not equal to 1. We're going to let f inverse of x, you know what, let's do it like this. Let's let log base a of x be the inverse function. So when we write down log base a of x, what on earth does that mean? It's just fancy notation for the inverse of a to the x. Don't let it scare you. It's just an inverse function. That's it. I like to put the subscript a to distinguish it as to mark it as the inverse of this specific a to the x. And so let's keep in mind, we've seen that f inverse of, you know what, let's not use a's and b's. Let's say f inverse of x equals y if and only if f sends y to x. And so when you play this out in our situation, we see that, okay, log base a of x is y if and only if a to the y is x. And this is really your friend. You want to make sure that you're comfortable with this. That's all you need to be able to work these problems out. So I wanted to work through some of the basic properties with you, properties of the logarithms. And again, this is supposed to be a brief review. I hope that it's brief enough but still helpful. So the first property is the graph, and I want to show you how you can come up with the graph. So let's graph together here. Let's do this. Whoops, come on, pencil. It's not wanting to work for me. There we go. We'll do this, and we'll do this. And so I want to do the case when a is bigger than 1, and I'm going to graph the exponential function we saw look something like that. And so you know what to do. You take the line y equals x, and you reflect your graph over that line. And so you end up with the following. You're going to go through this point. I'm going to have to shift it over a little bit, but it's going to look like this. And the purple is log base a of x. The blue is a to the x. And so you can see it. Of course, there's a similar graph for when a is actually less than 1 but bigger than 0. I won't graph that here, but there's a graph of the logarithm. Key point on the graph you should be aware of is x is 0. X is 1, y is 0. All right, the second observation is you can see that, I'll just write it here, you can see that log base a of x is continuous on its domain, okay? And which we should talk about that. What's the domain and the range? So the domain of the logarithm, log base a of x, is equal to the range of the original function, the exponential function a to the x, which we know is 0 to infinity. And so you can see you can't plug 0 or negatives into logarithms. And on a similar note, the range of the logarithm, log base a of x, is just the domain of its inverse of the exponential function. And we know the domain of the exponential is everything. You can plug in anything you want into the exponential. So the range of the logarithm covers all the y values. Now this thing really levels out, but it never stops climbing. It does keep climbing higher and higher and higher. I'm going to scroll way up for just a minute. If you scroll way up with me, when we laid out functions and their inverse, hopefully this isn't making you sick. These properties, right, we just wrote out this property for exponentials and logs, and then this property right here. When you compose f with its inverse, you get out x, and vice versa. F inverse with f, you get out x. And so I want to scroll back down now, and I want to write those properties down in this specific case with you. Let's switch to the different color here. So 4, we see that log base a of a to the x, this is f inverse of f of x, this is just x. And this is for all x in the domain of the inside. Well, the domain of the inside is everything. So this property holds true for all x. And then a raised to log base a of x. This is f composed with f inverse. This is also just x. And this is for all x in the domain of the inside logarithm, which means it has to be bigger than 0. So those are two really key facts there. Property 5, if you have log base a of a, you always get out 1. And log base a of 1 is always just 0. Property 6, this is absolutely fundamental. These are the rules of logarithms. We went over the exponential rules at the beginning. So log base a of x times y becomes log base a of x plus log base a of y. I won't write the parentheses there, log base a of y. And then log base a of x over y becomes log base a of x minus log base a of y. So product on the inside makes a sum on the outside. Be careful with these. People tend to struggle with these rules. And finally, log base a of x to the r is r times log base a of x. You can pull powers down on the inside and clean it up. So let's break this video here. I'm going to end with just a couple of quick examples, and then you guys can review this in the homework.